In this video, we talk about the idea of permutation. Now, the word permutation is new. It means the number of ways to line up, all right, to arrange the items, right? Sometimes we use the word arrange to indicate how do we do it, all right? To line up or to arrange the items, all right? Now, there's a very important idea in the permutation that the order, right, how one number come in front or behind the other is important. Alright, so 1, 2, 3, 4 is different from 4, 1, 3, 2, even though they have the same digit. For example, if you want to make a password, right, we want to make a 4-digit password from the numbers 1, 2, 3, 4, 5, 6. Alright, so how many ways we can do that? How many different passwords we can make from 1, 2, 3, 4? You know that for password 1, 2, 3, 4 is not the same as 3, 1, 2, 4. Nor is it the same as 1, 4, 2, 3, right? The order is important, alright? That is how to line up or arrange the items. Now, but before we answer that question, there is still one thing we need to clarify. For example, do you allow password like 1, 1, 2, 3? Do you allow repeat digits, right? So we have to split into two ways. You allow repeats, or you do not allow repeat. I cannot have passwords like 1, 2, 3, 1. You cannot repeat the 1, alright? So allow repeat or no repeat. If you allow repeat, you can have passwords like 3, 3, 3, 5. You can have passwords like 6, 1, 6, 6, and so on, alright? If there's no repeat, then the password can only be, 4 unique digits like 4, 1, 3, 5 or 3, 5, 6, 1, and so on, alright? So there are different calculations if you allow repeat or you do not allow repeat. So if you allow repeat, it's actually easier, because if you allow repeat, every digit is independent from the other, right? If I know, I can assume there are 4 boxes, right? In each box, you can choose between 1, 2, 3, 4, 5, and 6, all right? So in every box, there are 6 choices. You can choose between any of these 6 digits, all right? What you chose in the first one has no effect in the second one. Say if you choose 1 in the first digit, all right? Can you choose 1 in the second? Of course you can. You can also choose 2, 3, or 4, or 5, or 6, right? What you chose in the first digit has no effect on the second digit. So we call these independent events, right? So there are 6 choices in the first number. There are another 6 choices in the second number, 6 choices in the third, and 6 choices in the last, right? Knowing that they are independent events. They are independent. So what do we do with independent events? Do you recall? For independent events, we multiply them together. So we multiply these 6 together. 4 of them multiplied together. The answer goes to 6 to the 4th power is 1,296. There are the number of repeatable 4-digit passwords you can make with numbers 1, 2, 3, 4, 5, and 6. Now, it becomes another matter if the digits are that you cannot repeat the digits, all right? So once again, let me set up 4 boxes, all right? Now, imagine we start from the first digit, from the first box, right? The one on the left-hand side, and then we consider this the second one, the third one, and the 4th one, right? So for the first digit, how many choices are there? We can choose between 1, 2, 3, 4, 5, and 6. So there are altogether 6 digits to choose from the first box, in the first box, all right? So how about the second box? How many choices are there in the second box? Now remember, you took away 1 digit. Say you took away the number 3, all right, from the first box. So you can no longer choose number 3 in the second box. In other words, the number of choices in the second box goes down by 1. Because 1 digit is already taken in the first box, all right? So in the second box, you have 1 less digit to choose from. So that's why it's down to 5, all right? And then similarly, in the third box, there are now 2 fewer digits you can choose from. If you choose number 4 in the second box, all right, then you cannot choose the 1 because it's engaged in the first digit. You cannot choose 4. It is engaged in the third digit. So it's now down to 4 digits to choose from. And of course, finally, in the last box, you are down to 3 options. Alright, 1 is taken, 4 is taken. If you take 5 in the third digit, then 5 is taken. So you are down to 3 options. Alright, now they become independent, because if the choice is 1, then do you know which number I chose in the second digit? You don't know. Right? You only know that it is not a 1. So these become independent. So we multiply them together once again. 6 times 5 times 3 times 4. And the answer goes to, it's much less, it's only 360. Alright, these are the number of passwords you can do without repeating. Alright. In fact, we have a symbol to describe this. We have what we call an NPR symbol to describe this, right? Sometimes we use a symbol like this. Sometimes we use a symbol like this, alright? And the meaning of this symbol is that it is the number of ways to arrange or to line up our objects or our items out of n different items. That means if you have a box of n different items, right, these are the items, alright, they are all different, alright, we have n different items. So every time you take out R of them, right, I do not take all of them, I only take a subset, I only take R of them. Alright, they are R items, taken from the pool of n items, alright, and I put them in a line, I line them up on a single line, right? What is the number of ways you can do such lineup? Alright, what is the ways you can line them up? Alright, and the number of ways to do that, we have a symbol to describe it, and that is NPR or NCR or NPR, like this. Alright, 2 different presentations, they are just the same. Alright, so in the previous example, the ways to do that is 6P4. There are 6 different digits, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. 6 different digits. Every time we pick 4 of them, and line them up. The number of ways to do that, we call this 6P4. 6P4. So in other words, if you have numbers like 1, 2, 3, alright, every time you take 2 of them to line them up, so how many ways we can do it? We can do a simple counting. We can take 1, 2, we can take 1, 3, we can take 2, 3, and the reverse, we can take 2, 1, we can take 3, 1, we can take 3, 2, alright? So in this case, there are 6 ways we can do that. So we call that 3P2 equals to 6. 3P2 means we have 3 different numbers. 1, 2, 3, 3 different numbers. Every time we line up 2 of them, alright, so 3P2, there are 6 orange arrangement. So 3P2 equals to 6. Alright, this is just another example. Alright, but in general, we want to calculate what is NPR. To do NPR, we have to learn about another new thing, and that is the factorial notation. It is an exclamation mark. Alright, we'll talk about the factorial notation in the next video.